Oh. Hello? Oh, is that on? Oh, yes, it is. I was like, oh, it didn't sound very boomy around there. How are we all? A little warm? A little sweaty? You're not very chill, are you? All right, come on then. I have to do this obligatory selfie with you all. And I judge all of you every time I take this, because if you're not giving me all that energy, I will come and say it to you. So I like a nice big wave and a big smile, and you look like you're having the time of your lives. Because you are. It's the first day, your brains aren't too overloaded yet, and you have a seat, and it's not freezing, and there's been nice food, and there's sunshine. So I don't know if I can get all of you in one, so we're going to do two, and then I can compare the sides, okay? And you lot in the middle might get two chances, okay? So we're going to come this way and get this side of the room first. So remember, you lot, watch what they do and do better, okay? Right. Get it facing the right way. Are you ready? I'll count you in. No being mean, just big waves. Are you ready? 3, 2, 1. Good. Are you ready now? You saw what they did. You're all going to be miserable now. You're going to sit on your hands, aren't you? Like, we're not going to do better. Okay. Waving. 3, 2, 1. Excellent. I will look at those later and give you feedback. So, my name's Layla, and we're going to talk about Distribu-ready with the Modular Monolith, something I am very passionate about, and I'm really excited to share this with you. I am a little asthma-y today, so I apologize if I sound breathless or I cough. I will try and shield you from my lungs trying to exit my body, but just so you know, it's not COVID, okay? It's asthma. Right. So I feel the need to give you a content warning before we begin. When I created this talk last year, it was the hype of all the AI imagery, you know, where you give it a prompt and you get these weird multi-fingered weird stuff back. And so I went a little bit crazy and got some nice AI-generated images. Some of them are weird, but I love them. So just so you're prepared, okay? There are mostly AI-generated images in this. So I also like to start with this quote. And it's from Sir Richard Branson, who owns Virgin stuff. Complexity is your enemy. Any fool can make something complicated. It is hard to keep things simple. And we see that all the time in software development. Oh, we have this problem. Okay, let's throw all the resources at it. Let's go event-driven. Let's have message buses. Let's have this. Let's do all the things. And all of a sudden, we've made everything really complex. And that makes really unmanageable code. It makes it difficult for you as developers. It can sometimes make it worse for the end user. And nobody wins when we overcomplicate things. So I want you to bear that in mind as a mantra as I go and explain all the things I'm going to talk to you about, okay? That complexity is the enemy. All right, just hold that thought in your head. It's really important. So we can't talk about architecture without sort of touching on these two very common architectures. Now, mainly, when we start off, we see the monolith, and that's just a single unit. Sometimes it's a little bit more, but it's generally a single executable. All your code is in one place. And then the thing that everyone wants to have is a distributed system. Now, I will use air quotes. I'm in a bit of a habit, and I need to stop, okay? So we can count how many times I do it as a drinking game later. But anyway, I think distributed systems are used far too often. They seem to be the panacea for your problems, and they're really not. I get really annoyed when I hear about resume-driven development. You'll hear about someone going, yeah, I really want this new job, and, well, they do all distributed architecture. It's microservices all the way. So, this is what's going on in their head, and they come and implement that into your company. And there's like 5 of you. And I think, no, that's not right. And maybe you've got a couple of thousand users. So I see this a lot, and sometimes I hope I'm not going to offend anyone now. CTO-driven development from the golf course. And they're on the golf course, and one says to another, yeah, we've got microservices. And the other one goes, yeah, we do too, and then has to come back and follow through by going to the engineering team and say, right, the 5 of you, we need microservices. And you're going like, we do? Yes, we do, for reasons. And that kind of thing really irritates me. And I see a lot of hype around certain new Microsoft technology as well at the moment that's like, yes, it will make everything so easy for you to do your distributed systems. I'm like, stop telling people to do distributed. Stop it. I don't want people doing it, and I have said as much, and people, oh, yeah, you're right, okay. So, because they're complex, and we're going to go into why these are not great, and probably aren't right for nearly all of you in here. So what is a monolith? It is a traditional approach. All the components are munged into one thing. It's all tightly coupled, probably run on a single server. It is simple to develop. You can right-click publish it. Yay, winning. You can also debug it. You can put a nice breakpoint somewhere. You can follow the path of the code. It makes for a nice, easy experience for you as a developer. It can be difficult to scale and maintain because it's tightly coupled. If you touch one thing, it might break something over here, unless you have, good tests in place, and you know that that's all available to you, and you're not going to break things. I mean, I worked on a system where you literally touched one thing, and 7 different things would break because we didn't have we didn't have even one test, not one. No integration tests, no unit tests. We had a team of 5 testers who would, test the UI and compare stuff against the ticket that we were working against, and that was it. That was it. It was hellish. You got a note saying you broke it. You broke this over here. Like 4 weeks ago, that commit you did broke this, and you're like, what did I do 4 weeks ago? So that makes it quite difficult. You get that in all architecture, but generally, when you've got everything tightly coupled and interdependent, that can really cause problems. The only real way to scale a monolith is in its entirety. You can duplicate it, or you can throw more compute at it. That's kind of your only option. But it's a nice experience for you, and probably what most of you use and really need. So microservices architecture, it's everything divided into supposedly loosely coupled services and deployed. And the big selling point of this is that you can deploy them all independently. Nothing goes wrong with it. It's amazing. You can scale this service over here from 0 to a gajillion. It's all on Kubernetes. It's just really, amazing. You can do, 300 million deploys a day if you like. These are the stories I've heard. There's a big fashion retailer, and they've spoken at big Microsoft conferences about how many deployments they do a day because of this architecture. And probably in their case, it's a really relevant useful technology for them. And they've got a team of like 150, if not more, engineers working on this. So they can do all of this. So let's go to why you might think you need to go to a different type of architecture. And that's generally because you want to scale and meet growing demand. You've got a lot more business coming in, perhaps, or you are expecting more business. So you want to scale and meet that. That sounds good. Not any type of CTO or resume-driven design. You're thinking, yes, we've got a lot of traffic and we're getting bottlenecks, so we definitely need to do something. So your options are to scale your current monolith. As I said, you can scale it vertically by giving it more compute, or horizontally by instancing it and putting a load balancer in front of it, etc. And then you can start to look into the code and optimize it and try to eliminate any bottlenecks. Just make it smoother. You know, those multi-tiered if statements and all those loops, maybe take some of those out. Maybe, you know. Or the other option you're presented with is a distributed system. And as we've said, that's breaking your app up. So you are going to have to go in and find boundaries and decompose it. So if we start to compare those two architectures, that monolith is very easy to debug, like we discussed, but microservices are not. Because they are all disconnected, it's very difficult to follow those breakpoints across. They're also really difficult to run on your local computer, your development box, because there are so many different dependencies, and they may be coming from other teams, and you may only have like a container. So now you've got Docker in the mix, and now you're running that, and you've got an instance from this team, you've got a container image, and you're running that, and now you've got RabbitMQ over here, Redis there, and God knows how many different databases, and you're having to stand that all up on your development machine or some kind of development environment. And you can't just always drop a breakpoint in some of these encapsulated services that are running. Maybe you don't have access to that service code. So you'll fire something up and you're like, well, is it in my code? Is it in their code? And it makes for a really frustrating and difficult to develop system. Now, updating or maintaining, as I've said, with a monolith, it can be fraught with danger. And you have to go in and be very careful that you don't break other things. Make sure that your tests are in place and passing. Now, the promise of microservices is that it's all encapsulated. You touch that, you deploy it. It has zero impact on any other service. And it's supposed to have very little disruption in the whole environment. This is why you can deploy things multiple times a day. And this is the promise that we're all made, and it all sounds so good. The scale and growth with a microservice, you can scale all of those things independently. Now, the deployment of a monolith is generally easier, as I said, ingest or not. You can right-click publish, okay? You can do it. You can push it in, put it into GitHub, set up a GitHub action, and it's all done as a single assembly, and off it goes. It's nice and easy. It's just that DLL. But with microservices, now you need to orchestrate all of this. You need to think about how you're going to get this out. Is it going to require a restart here? How are you going to monitor that it's healthy? Is there anything going on that's going to break it? So it can be difficult, and you probably want someone who is specialist to deploy all the services and make this work for you. So it does come with more difficulties, as well as that promise of being able to deploy your changes then and there and not have to wait for some other change in the monolith that, we can't release it because they're still doing that and we have a dependency on that, okay? So it is both good and bad. Now, with all of that, it probably sounds quite straightforward, and this is why so many people are in the predicament that why not go to microservices? It seems to answer so many of our problems. We're not having to wait for Bob over there to do his work so I can release. We can scale it all independently. It's going to be cheaper. just going to be cheaper to scale it because we're not scaling the whole app. We're only scaling this one thing that's really busy today. So microservices come at a cost, a big cost in my mind. And I'm not talking the pennies. I'm talking simplicity. We have now made a hugely complex, very interdependent, not dependent, microservice system that we now have to do because we have to have everything out there. Everything needs to be functioning for all of it to work together. It's not like, hey, I've published it, it's working. Everything needs to work in tandem. And that is really hard. We now need to make sure that we've got our message bus there, that we've correctly implemented it, that we're handling the error codes. Now we've got to have extra telemetry and observability. We've got 1,001 different services that we're having to monitor, who owns what. That's not good. They are very, very complex, and complexity is our enemy. So what do we do? I mean, there's no easy answer. You need some of the things that microservices offer because your monolith isn't cutting it. So let's think about the journey to distribution a little bit more. All right? We know it's complex, but how do we actually get there? And I think this chart shows it. We've got our distribution and our modularization. And our monolith isn't really modular, and it's not really distributed. It just sits in that bottom left-hand corner. And we definitely want to go to microservices. And I feel the mistake that many development teams do is to try to go direct to microservices. And you'll hear lots of patterns, like how you do it, things like strangler fig, and this, we need to go and do this architecture. We're going to DDD the hell out of this thing because that will solve our problems. And we try too hard to make this transition in one go. And that's when we end up here with a distributed monolith. Now, I'm not saying that you won't end up on your way there in a distributed monolith, but the problem is that many teams get to the distributed monolith, have a minor to major freak out that this is horrific, this is terrible, and then get stuck there. They don't keep pushing on through that pain of being a distributed monolith. So what are the dangers of the distributed monolith? Well, this little dude's going to jump out and get you, okay, because this is not a good place to be. You may go through that town, but you definitely do not want to stay there. So what is it? Let's think of these two services. This is services in our distributed architecture, and they share this database. This is something else you will hear me rant on about. Bless you, whoever that was. It was over that way. Never, ever, ever do this. And I'll tell you why, okay? Let's say we want to do some updates to one of these services. Here we're going to do a database update. Yay. We needed to do it. It's fine. All right, now I want to go and deploy my microservice because that's my right. It's a microservice. I can deploy it whenever I like. No, sorry. You've just, what about this service? This service now doesn't really work with this database. We've coupled them. That little guy has to come along. We have to go and change that other service to match the migrations or whatever changes that we've done on that database because they are coupled. We can't deploy them independently. Now, that's a very simplistic look at what a modular, not a modular monolith, well, maybe, but a distributed monolith is this coupling between our services. And that is the antithesis of what we want to do. We want to decouple everything. And your life as a developer just got really hard. You have all of the complexity of a distributed system and none of the benefits of those independent, discrete services. So we also have none of the ease of the monolithic development and debugging. So who wants to be there? It's not really a good place, is it? I think this is one of the worst places to be, and this is where so many developers and teams end up. Now, the golden rule that I want to say is something I borrow as a mantra from DDD. This has been around a lot more than that, but it is something that comes up a lot in DDD, and that is loose coupling and high cohesion. I'm not a DDD person, but at my last job, I worked with a lot of people who were, and it rubbed off on me. So, I don't profess to do any of it or understand it to any depth, but it has rubbed off on me, and the main thing that did was loose coupling and high cohesion. So we need to bear that in mind as we progress. Now, there is a much more pleasant journey than the one I showed you, one where you don't generally go through that scary town with weird monsters jumping out of your keyboard, and that is this way. So now we've added in this modular monolith, and we can head towards that instead. So rather than trying to go to microservices directly, we're going to go here. Now, eventually, you might decide that you want to go microservices, and that's okay. Your application is now going to be in a state where it's prepared and ready to do it. But you might not feel you have to now. So we don't want to be the guy on the left with our distributed monolith. We definitely want to be going towards modular monoliths. It is definitely a happier place to be. So let's go back to this chart and think about this third option that you're now aware of. And it appears like it's the best of both worlds, doesn't it? Because I've just told you it's amazing, and I'm standing up here talking about it, that it's the best. It has a lot of the problems of both, and that's really important. Our regular monolith is simple. What we are now doing as we move towards a modular monolith is adding in complexity. So I need to stress that. It isn't, just the answer to all of your prayers right now. It is definitely going to add more complexity. So you need to be prepared that this is the correct route for you. So what is it? It's an application that has been modularized into separate, possibly interchangeable modules or components. And this allows for improved maintainability because we've got this encapsulation like you would in a service. So theoretically, you should be able to go in and touch something in one module, and it has minimal impact on another module. So we still have that idea of it. However, we are a single runtime, so it should just be that one executable. So debugging is easier, deployment is easier. We're not having to orchestrate a gajillion different services to work in tandem. So we've kind of got that a little bit better. And this is where I want to introduce the KitKat pattern. I don't know why ChatGPT thinks KitKats kind of look like that, but we'll go with that. Not ChatGPT, I didn't use that. That's a talky one, not a picture-y one. But this is a pattern that I like. I invented it. I'll own that. It's fine. And it makes sense to me because this thing. I have to ask you, who eats their Kit Kat like that? That's way too many hands. You're all monsters. You deserve to live with that weird thing coming out the keyboard. Who in their right mind eats it like that? That's not right. You nibble all the chocolate off the edge and then eat the wafers layer by layer. Maybe that's not normal either. But if you are a normal Kit Kat consumer, you break a finger off, don't you? And then you nibble that. So I like to think of the modular monolith like a Kit Kat. We've got the entire bar. It's one Kit Kat bar. And a finger represents that individual module. If you snap a finger off, it's an entire self-contained chocolate bar. You could give it to your friend. You could swap your Kit Kat finger with their different colored Kit Kat finger. Maybe they got the nice matcha green tea one or a peanut butter one. And you could swap those. And you still have this complete self-contained module, or you have it as its entirety. So I like to think of it like that. And that makes sense in my weird brain, and maybe it will help you as an analogy for what it is. So now you're probably thinking, this woman is talking about Kit Kats and weird monsters and weird journeys. Don't want to get in a car with her. But how does this work in your application? So let's take your plain old monolith. We've got our API, logic, data access layer, and I don't really care if you have any of these, whatever the latest buzzword of architecture is. You can apply these principles to whatever you're doing. And I am going to use end here because I think most people will have experience with that. But you can overlay any of these on top of what I'm saying, all right? So I don't care. It's no interest to me what architecture you are using. So let's think about how we'll slice it vertically, or like a pizza, I don't know, whatever you do. And we're going to have all of these self-contained modules, and they have all their API type stuff, they have their logic, they have their data access, and it's all completely encapsulated. Now, you might be thinking this is very similar to vertical slice architecture. However, it's not the same. So if you're unfamiliar, vertical slice architecture is where you implement a feature at a time as in its entirety in one folder, for example. So if you've got to touch all these different layers, you will do that in one folder. So if you go back and say, oh, what did we do on this feature, you can see that it's all in one folder. And that can be applied to any type of architecture. You might be doing that in a distributed system, your regular monolith, or indeed your modular monolith. So it is different. There are similar ideas behind it, but they are not the same. So how do we go about decomposing our application? That's kind of a big thing. And this is not any less complicated than if you were trying to decompose your application for a distributed architecture. This is the hardest part, often, of how you approach your application. So we want to remember that loose coupling and high cohesion, because that's going to really help us define what our modules are. So just to remind you that elements within a module have high cohesion and are tightly related to each other. So everything that is to do with one particular domain is all going to be in the same module. And we keep those loosely coupled so we can have that minimal impact when we go and work on something. Now, this is a more in-depth one of cohesion versus coupling. And it goes into what they're not, basically. So if we have low cohesion, that means that we've got things, I don't know, from the customers lumped in with the inventory or the staff or things like that. And this is where it starts to get muddled and complicated, and we don't really want to be there. We want to have these very clearly defined boundaries. And if things are coupled, we've got that case that I showed you earlier. We're coupled by a database or another library. We've coupled things, and then that makes things difficult to deploy and well, just work on, because we don't know what touching something here is going to do to in the other application or other module. So we need to start incrementally with the largest chunks possible. And this is generally a good approach because we want to try and encapsulate as much of something as we can. So this is going to be a contrived example because it will be easier for everyone to understand. So everything to do with something like orders, we're going to lump in orders. Everything in inventory together, notifications, dispatch, it all gets lumped together in these big, big modules. Now, as you progress through your decomposition, sorry, that sounds terrible. Do not decompose here. It's warm and you will be smelly, and none of us need that on top of everything else. So we have our orders, and we might break that down into further modules. Now, those modules might be encapsulated within the bigger module, and other modules might not have any awareness that there are further modules within it, or they might come fully out. That's entirely up to you and your system. And then there are ways that we can start to come to our decomposition, and that might be code first. That's probably where, as developers, we might like to go. And we'll start decomposition in the code base and then move to the data. Or you might choose to do the data first. And what might that difference be? So if we go for the code first, code is generally easier to extract from something else than data. So you'll get faster results. You'll get that code out, you'll be like, yes, it's beautiful, it's modularized, it's awesome. But the danger comes if you've done all this work on your code, and then you go to your data, and your data is not able to be decomposed to match your code. And then you might actually end up having to revert all of your code because you're going to have to come up with a different plan. So you need to make sure that you're talking with DBAs or looking at it all holistically. Now you might choose, well, we're going to go data first. And I would generally recommend that if your data is more complex and you're thinking, yeah, I'm not sure if this is going to work. So you can go in and have a look at doing your data, and then the code often follows quite easily after that. So, but what if you did your code first and then didn't go any further? I mean, you've already heard me yell at you, basically, for even thinking that you might couple your services via data. But we're not in microservices. We're in a monolith. So this, you hear it here, is OK for the time being, as long as you know. All right? You don't actually really need to go any further if you don't think so, or you don't have the time right now. That's OK. We want to be pragmatic, not dogmatic about these things. And I always try to drum that home. I may sound like I'm preaching to you up here, and you may think, must do it exactly this way, or someone else's way, or a way you learn on a workshop. But you need to be practical for your needs, your application's needs, your customer needs. Basically, you need to look at it in each instance. Now, as long as you know that by leaving that data undecomposed, you're accruing a technical debt. Because maybe at some point you'll want to take that module and deploy it independently, but it is coupled to the rest of the modules or another module. So you are accruing technical debt, which is OK as long as you know what that technical debt is. So this is a huge thing as we start to do this journey through our software, is the complexity and adding in technical debt. Now, I like to think that you might document this, you'll have this in a vision, you'll have a long-term plan. But as long as you're aware of it, technical debt is OK. So, how is this Distribu-ready? That was the title of the talk. We've now got this modular monolith, but are we going to actually distribute it? How is this ready to go? So if you think about that Kit Kat, we can break that finger off, and now it's its own self-contained application. We can take that, we can give it an executable, we can put it in serverless, so a Lambda or Azure function or its own web application, and we can shove it off, and it's its own complete module or microservice. And DHH came up with the Citadel pattern. I don't like that. It doesn't mean anything to me. A citadel, that doesn't invoke anything in my mind. So I'd like to introduce you to the satellite pattern. So a central modular, maybe, monolith with self-contained modules that can be broken off and become satellites. Now, I put modular in brackets there because you don't necessarily have to have a modular monolith to take, say, your email service, which might be peaky in work or really heavily loaded, or be a long-running process, and have it in the application. You can take it out and you can deploy that independently as a satellite. So now you've got the flexibility of just 2 executables. And this now can be scaled from 0 when you're not sending out notifications or emails or doing whatever that service does. And then when it comes under load, you can scale it up appropriately. So I think this is a really good place to be. We've not got a million different services. We've just got our main application, which has all the benefits of easy deployment, easy debugging, and we've got a few services that we can put out and scale as needed. So you could think of this as carving off, like carving off an iceberg into a mini iceberg, and I think this is a good place. I like this. They can be converted into standalone apps, you can containerize them, it's great. So this leads us to an important question. How? As I've just gone through and this is easy. It's complex, but it's easy. You just carve it all up, and now you're here in this wonderful place where you can just take things out and deploy them independently. So I'd like to introduce you. Well, I'm not going to introduce you yet. We have some questions first. There we go. We want to make sure that our modules remain completely independent. That is actually quite a difficult thing. We'll get to how you do that. Now we've got modules that need to communicate across boundaries, and we also need to enforce the architecture. Now I'm going to introduce you to the project, Tacky Tacos. So I want you to think about all of these things as we go through this example of how you might do it. So this might be a somewhat contrived example of modular architecture, but this might be what it looks like. We have all of our logic containing all of our modules. We have a web API through the middle, and then we might have a client. So that could be anything you want. That can be some SPA, JavaScript, Blazor. It might not even be there. Maybe it's an API service, but you've got that. But the main part of your modular monolith is this web API. So things to note is that web API is going to be the glue. It holds everything together. We are going to extend our API endpoints from the modules into this web API layer. They'll have all of their endpoints self-contained, because we need to maintain that encapsulation in case we carve one off. And we need to have strict rules on what our modules can and can't do. We need to ensure that they only communicate with each other via a contract. So if we start delving into what our application looks like, the best way that we can do it in .NET applications is by class libraries, CSproj. Okay, that's the only real way that we can modularize something in an easy-to-maintain way. So we've got our web API, that's the executable. And then our module here consists of the main logic, the orders, possibly the tests, and then contracts. And those contracts are important for how different things communicate. So they're going to be your DTOs, or data transfer objects. And we can see that all of these modules follow the same format. We've got the main logic, we've got tests, and we've got our contracts. Now, the web API is the only thing that is allowed to reference a module directly, because remember, it is the glue. If we don't have that referencing those projects, we're not going to be able to access them. So that's the only thing that has access to all of the modules. And then individual modules can only communicate or know how to communicate via the contracts. So what is this communication? Well, for external communication, we can use any sort of HTTP or anything like that. And what will happen is we're going to have a request come into the web API, and then that is going to be routed through to the logic, the appropriate logic there. That will happen through all the different modules. In this case, we're going to make a request to the orders module, and that will create an order. And then we'll let the payments module know that, hey, there's an order in here, we need to collect payment. And so we've got this sort of disparate thing going on. So yeah, here's our complexity. It's not all going through with a service that does it all at once. So how do those endpoints look in our individual module? Here we have minimal APIs. And one thing that I'm a big fan of in general is extension methods. So we can see that this is static. And the main thing to note here is the keyword this. And that's what makes this an extension method. We are actually extending web application here. So you know in your program file, and you have all of those dependencies, builder.services.add, singleton, transient, scoped, and you've got a gajillion of them. And then you've got all of your APIs or all of your middleware down there. And now your program.cs file is this big. You can use extension methods to tidy that up, just like this. And then you can do that for your minimal APIs by bringing those into another extension method. And then when you come to that, here's your service ones as well. So we've got our singleton. You can see this one is extending iService collection. We've got the keyword, again, this. Now, you could have that extend your web application builder. That's entirely up to you. Whatever makes you feel happier. I flip-flop between the two. And all of these extension methods are what you're going to have inside your module. And then in the glue project, the web API, we can start to call them. So we've got our services up here, and you can see that we've got the orders module dependencies, the payments module dependencies, menu. And we need those registered here because this is where our IOC and version of control container is. We have no way of registering these dependencies in our modules because they don't have an executable. But we don't want the code to be in here. That code needs to remain in the modules because it belongs to them, and then that will enable us, if we want to distribute that module, to take it out in its entirety. So it's really important that everything belonging to them stays within them. That's the Distribu-ready bit. And then we have the same thing going on with our web application extensions down here. So this leads us on to the inter-module communication. That's quite basic to understand that. You might have done something like that already. But when you come to your inter-module communication, it's where it gets a little bit more dicey. Now, if your module has a public interface, so that could be just some kind of something through the contracts, or maybe you've allowed your rules to allow referencing modules, because those are my rules, that the web API is the only one that can reference a module, but you might have different rules. This looks like it's okay. We can have them communicate directly. But then that looks like this. And that, to me, is very confusing. All of these modules are now chatting to each other. We've got all this coupling. When I come to remove, say, that module in the top left, I need to go through and change how all of those other modules that have a dependency on that module in the top left actually communicate with it. So I don't really like this methodology of doing it. It works, but it's not ideal. What this is easy, but it's got hidden complexity for the future. And I've had people come up to me and say, we just got our modules communicating directly because everything else we tried was too hard. But remember, I said it was easy to add complexity. It's doing things simply and well that is the difficult part, okay? So rather than direct calls like that, we want to go and use something like a mediator. So if you implement a mediator pattern, yes, things are still coupled, but we are only going through one place. So if we take one of those modules out, we only have to adjust how it's associated with the mediator, not with everything else. And then the mediator will just handle the communication with the other modules as it always has done. So by taking that sort of complexity out and putting the mediator in, that's the main use case of a mediator, we've simplified that. It is harder to do. You have to go and think logically about how these are going to do. You have to register all the different things. But it makes it more simple in the long run. Now, you could go on to use messaging, especially if you implement your mediator in such a way that you can just take out your mediator code and put in a messaging code. And you can easily do that if you give it some proper thought. So what is a messenger? Messenger. We have a producer, and that's one that is creating the messages, and it queues them up into the message queue or the message broker, and then a consumer can subscribe to that and dequeue it. A producer can be a consumer as well, so we can have this all going every which way. And that also takes away that inter-module direct dependency. And it can look like this. We've got decreased coupling, and you can see very easily that that totally mirrors what the mediator is doing, which is why mediator is not mediator, the NuGet package, mediator pattern is a really good way forward. Now, you may choose to go and use mediator because of whatever reason, but I'm talking about just a pattern here. Just like any other pattern, you can go through and implement this. And it's worth knowing how to implement a mediator yourself. So when we've done that, we can easily exchange that mediator for a message bus. And our system like this with a message bus is often referred to as event-driven or message-driven. And I see a lot of people wanting to go straight to this. But it does add in so much more complexity, okay? Things that we have to note are that the web API is the place where all the producers and consumers need to be registered. So there's this sort of mix-up in your head that everything is munged together. We have to think about that. I'll come back to that in a minute. When we go straight to messaging, you have to be really sure that you have people who understand how to implement a message bus. There we go. I'm not going to say messenger. Message bus or a message broker correctly. All right? There's so much complexity in that. And we're making yet another thing that we have to deploy. And you have to ask yourself, do we really need this, or do we just want it? All right? Now, I'm going to go further into what this might look like as well, because maybe you decide that you do need to go event-driven, or you are going to start making satellites, so you need all of them to communicate. And there's two types of messages that you want to have in it. The first one is thin messages. And that's where you might do an update. So you'll have an ID and a status change of a particular record. It's quite lightweight. Lots of different things can subscribe to it. There's not additional information. Now, if a service or a module needs additional information, it can then ask for it based on the status of that update it received. So how does that look? Well, in the case of Taki Tacos, and this is the same with a mediator. You can implement this same pattern. You have to do it more manually, but you can totally mirror this with a mediator. We have an order placed, so it goes to the order APIs within that module, and we create the record. And we also then go, as we saw, and make a payment request. Now, when the order is created, that has an unpaid status. And when the payment is taken, we need to update that payment status to be paid. So if we do that through something like a topic exchange, we'll send out an update that says orders update paid along with the ID, and then we can see that the order module is listening for that. It's listening actually for anything with an update. So orders.update.star, anything that's an update, because the order module is the data owner. So any change to status, it will be picking up. Now the other thing that's listening to that order update paid is the kitchen in this instance, because they need to go and process the order. It's paid, now we need to start cooking it. But remember, that was a thin message. It just had the status and the ID, but that doesn't help us decide what the order is. So that's where we have to make a request, which again is a thin message, to the order module to say, hey, can I have the order details? And then that in turn is going to send us a fat message with everything that we need to make our order. So that would be what tacos, what the toppings were, the quantity, and that will come back in. And that can all go through the mediator or the message bus. In the case of the message bus, it's kind of, I guess it's all asynchronous, because the order doesn't care what's listening to it. It just listens and responds. So this is quite nice, because if we do come and make a satellite, everything is ready to support that new architecture. But do you see how much more complexity we've added to it? We now have to think about what's listening, what owns data, because the payment can't tell the kitchen what stuff it has, because it doesn't know. It just was saying, hey, this order ID and, 300 kroner, please. That's what it can do. It only has certain awareness of certain modules, because it's highly cohesive and everything's loosely coupled. So it is more complex. You also got to think about the idempotency, I hate that word, of your data, because, well, what if something else makes that same update, and then we're overwriting updates or changing things? So you have to make sure that everything is working how you expect it, and think for potential issues when you do this. So it is more complex. We really have drastically increased the complexity of the system. We have to consider all this error handling and implementation details of a message-based architecture, and that is no small undertaking. But our modules are now loosely coupled and easier to convert to satellites, which is fine. But I just want to urge you to think before you go straight into this architecture, because I know event-driven is really popular right now, and loads of people really want to do it, and you want to do this type of thing, but do you need to, okay? Because you could be making life a lot harder for yourself. Now, preventing the inevitable, the big ball of mud. This is particularly important in our modular monolith, where everything is in the same code base. It's not like a microservice where everything is off in separate repos, possibly, and things like that. It's all there together. So what's to stop the new person coming in and going, well, I'm just going to connect this here, and I'm going to make a reference to this order, this other module, and all these internal methods. Well, I actually need this to be public, so now they're making it public, okay? And now it's everything, all your vision of your beautiful modular monolith has gone out the window. So there's a few ways that we can enforce the architecture. That's code review, compile time, automated tests, and a style guide. Code review, we can include pair programming here. We have sharing of knowledge. So if you've got someone who has been on the project a long time and a new person, you're sharing. Test. Woohoo! New batteries. Yay! Okay. I should have just wound down as well then. Okay, so we have pair programming, we've got sharing of knowledge, which is great. But you have to make sure that the person you're pairing with actually knows what's supposed to be happening as well. And they may be just as clueless about the original vision as you are, okay? And that's a big problem. So I think there's a big culture change that needs to come in here. You need to think about documenting the original vision, and you need to think about your onboarding. And you need to think about how you are going to share this original vision. Think about how many of you work with the original visioneer of your architecture? No, they've probably gone on to another job. They've done their damage by doing their resume-driven development, and now they're gone. So, that has a big if on it. Do they know the architecture themselves? And I also think pair programming is better spent, because that's precious time, on sharing knowledge, the good stuff here, and challenging the status quo. Not going, well, actually, you just did that and went to there, and you really shouldn't have. That was wrong. That was a bad idea. You stupid. Okay, we don't want that kind of atmosphere. So compile time is another way. This is a really easy win. By adopting private by default, or making all of your modules use the internal accessor, that's great. Now, some people will say, yeah, but you can use reflection or that new unsafe decorator thing that came out in .NET 8. But my compiler is still going to tell you that you shouldn't be doing that you now knowingly are circumventing my modular design, and that's on you. But what we can do is tell the developer, this is wrong, you shouldn't be doing that. And at least when they go and break the rules, they're knowingly doing it, rather than, hey, everything's public, it's free for all, try and figure that one out. Okay, so try and use that. If with your tests and things, remember you've got that internals visible thing in your CS proj, just to make things visible. You don't have to go and make things public just to access them. So remember this, we have this nice layout. We're encapsulating our code inside our modules. And then we have these public classes in the contracts, so our DTOs, that our modules can use to communicate. And how that might look is that we'll send a message to the kitchen DTO, the kitchen module, and it knows how to translate that because it knows how the order DTO wrote that and what values are, and then it can start to decompose that to how it wants. So it's like this interpreter between our modules that we've created by having these contracts. We're allowing them to know their mutual communication language. So that compile time is immediate feedback. That compiler is very good at yelling at you. It does require your code to conform to the architecture, and it can be circumnavigated, but that's on you, remember. It is undocumented. Automated tests, such as static code analysis tools and architecture tests. So the benefits with the analysis tools are they're automated, they're self-documenting, you can share them across repos. They give you a lot more as well, reporting and integration. They can detect all sorts of stuff. So they do give you a lot more, but you do have to set them up, all right? But they are great. There's quite a few out there, so you could go and have a look at them in general, not just for enforcing architecture. Now, tests are really interesting. The benefits are they are automated, self-documenting, pretty instantaneous feedback. You can run them. They'll say, hey, you shouldn't have let those two talk to each other. And it has all the benefits of tests, but just for your architecture. Now, like any type of testing, they take time and discipline to implement, and you need to have good coverage. There's only, doing it halfway doesn't really help you because you might not cover all the different things. So you really need to have good coverage. This is an example architecture test, and you can see that it's like a fluent API, which is really nice. And you can say that, in this case, classes that reside in assembly kitchen module should not depend on any types that do not reside in assembly module. Okay, so we've got this. We're saying what the dependencies are between things. Now, a style guide has the benefit of being documented. Everyone loves reading documentation, don't they? Yay! Here's the manual. And it is a good resource for newbie members to go and read. And people who've been there for a while. An example of a style guide is the C# style guide at Google. You can go and take that and build on it. It's pretty extensive. So I think that would be a good start. You can then embellish it with your architecture and what's allowed to talk to what. So to summarize the modular monolith, use where modularity is important. But the overhead of managing and deploying microservices is not justified. If you do not need the importance of modularity, don't bother, okay? Because we are creating more complexity. You need it, all right? Don't just go and produce a modular monolith because you now have heard me talk about it and you want to do resume-driven development and go and do it. Do it because you have a requirement. So key things to remember: be pragmatic, not dogmatic. Through all of your software development, think about the practicality of it. Be aware of the technical debt and high cohesion, loose coupling. All right? Those are some really good rules to live by as a software developer in any field. Now, the question you all want to ask is, can I use .NET Aspire in a modular monolith? Yes, you can. Yes, it makes things good. And that's one place where they're like, hey, go distributed. No, stay with your modular monolith or even your monolith. Okay, you can develop in Aspire if you need to, because again, you're adding some complexity. So make sure that you need it. So from me, I have a YouTube channel where I explain a lot of these things. There's, some of these patterns. I've not been working on YouTube yet, so they're a little bit older. More recently, I've been working on YouTube because now I am a game developer. So I work on Twitch a lot. Most days I stream on game development. If that floats your boat, you can come and chat to me or watch that. If you want to hear more on my opinions, on my strong opinions on modular monoliths, there's a .NET Rocks episode that came out last year where I talk about it. And then that's me, another weird AI image for you where I kind of look like I might come and steal your children and feast on their tiny little bones. But thank you very much. You can find me in all those places. And thank you, Dream Studio, for the very weird unhinged images. And enjoy the rest of the conference or festival. Thank you.